Hello everyone, this video is going to go through percentage yield. We've got 3 questions here today. The first one is pretty straightforward and the 2 second ones will involve some reacting mass calculation knowledge. I do have a video on reacting mass calculations which is in my chemistry playlist, and link is in the description if you would like that. Please do like and subscribe if you find this video to be helpful, as it will help me out and it helps me reach this content to more people. Okay, so let's make a start. So part A is asking you to calculate the percentage yield, which you can work out using this formula here. So the only 2 things we need is the actual yield and the theoretical yield. In any question, the actual yield should always be less than the theoretical yield, since the theoretical yield is the maximum possible amount of product that could be formed from a chemical reaction, assuming there's absolutely no losses whatsoever. Now in practice this never happens, which we'll talk about in part B when we are giving 2 reasons why the actual yield is less than the theoretical yield. So let's just make a start on part A. So it's saying magnesium reacts with oxygen to form magnesium oxide. Here is the chemical reaction. We have a student calculated that the theoretical yield of magnesium oxide was 10 grams, but after doing the experiment, the student obtained 8.2 grams of magnesium oxide. So this one here would be the actual, since it's less than the 10 grams, which would be the theoretical. So if I plug those numbers in, we've got 8.2 divided by 10 times 100, and if you put that into a calculator, that would give you 82% yield for question 1. Okay, so once you've got the numbers, it's pretty straightforward. You just put them in the formula and calculate. So part B, let me give you a few answers for this. So one of the first ones could be that we have side reactions occurring. So side reactions are where some of the reactants go through different reaction pathways, so they might react with different things, impurities in the sample. So side reactions. A second one is that some reactants / products are lost when being transferred, meaning if I take a reactant out of essentially a pot and put it into a test tube, when you're moving samples around in different things like beakers and test tubes and things like that, some of the product or reactant could be stuck to some of the test tubes or beakers or any of the glass, the apparatus. So if that happens, that's where some losses can be created. And also, give you a third one, you might have that you have unreacted reactants, so they don't all end up reacting. Okay, you might also have that one of the reactants is limiting, meaning since you're reacting magnesium and oxygen here, in practice usually one of these would be in lower supply, so one of these will actually run out first in this reaction, and that means that one would be the limiting reactant, and that one would make sure that not all of the reactants end up as products. Okay, so I'm just going to get rid of all of this if it wants to go. There we go. Alright, question 2. So these ones are a little bit harder, as you will see in a minute. So we have magnesium reacts with oxygen to form magnesium oxide, same chemical reaction. This time it's saying that a student burns 6 grams of magnesium. And we've got some relative atomic masses. we will need to do some reacting mass calculations. So let me have a go at that. First thing I'm going to do is just write the chemical reaction down. There we go. And it's saying a student burns 6 grams of magnesium. So if I write 6 grams here for my magnesium, that should say M for mass. Then what I've got is to work out my moles as well. Alright, so if I wanted the moles of magnesium, remember I need to firstly work out its MR, which comes from the periodic table. But since they've been very kind, they have actually given us the relative atomic masses here, which are the numbers that you'd gather from the periodic table anyway. So if you used to see magnesium in the periodic table, it would have the number 24 above it like that, and that's the number we use for the MR, okay? So for magnesium, it's just straight magnesium. That would be 24 then. Ooh, let me just change to colour. 24 grams then for the MR of magnesium. And to calculate moles, moles is equal to the mass in grams divided by the MR. And so for this one, it's going to be 6 divided by 24, which would give you 0.25 moles. Okay. So that's magnesium. Then I need to work out the one for magnesium oxide. So obviously we don't know anything about the mass for magnesium oxide. MR we can work out. So we've got Mg and O. So Mg's got 24 above it, and you can see oxygen here, as they've wrote, is a 16. So it's 16 and 24. Okay, so add those together, giving you 40 for magnesium oxide. We can't get this mass at the minute. What we need to do is to use what we call the mole to mole ratio, and that will allow us to work out the moles of magnesium oxide. So since you see that there's a number 2 in front of magnesium and a number 2 in front of magnesium oxide, this tells you that 2 moles of magnesium will equate to 2 moles of magnesium oxide. And so if that is the number of moles for magnesium, then it will be exactly the same for magnesium oxide, since the ratio here is 2 to 2. Okay. So now I've got the MR and the moles. If I want to work out the mass, then since it's at the top of the equation here, I will multiply these two. So multiplying those gives me a quarter of 40, gives me 10. So 10 grams of magnesium oxide. Okay. Then what I also need to do is to work out the mass of oxygen as well, because we need the total mass of the reactants and obviously the product there, and that will allow us to work out the yield. So MR for oxygen, noticing this time that oxygen's got a 2 there, so that means that it's 2 oxygens bound together. And since oxygen has this number here, which is 16, then we do 2 times 16, which will give us 32. Okay. Now to get the moles of oxygen, you should notice that there is no number written in front of oxygen. But in fact, if there's no number, remember it is thought of as just a 1. And so this time, when we work out the moles, we're using the fact that 2 moles of magnesium will produce 1 mole of oxygen, since it's 2 to 1 here. Okay? So that means if I want to go from here to here, I need to divide by 2, because it's 2 to 1. So if I divide that by 2, whoa, put that back there. If I divide by 2, it's going to give me 0.125. Okay, and finally, if I multiply these two together, that's going to give me the answer I need here. So that is in fact an eighth of that, which is the same as a quarter of 16, which is 4. Okay. So there's everything, basically. Effectively, this is what you would expect if this reaction occurred without any losses whatsoever. 6 grams of magnesium reacting with 4 grams of oxygen, which produces 10 grams of magnesium oxide. But in practice, this never ever happens. So this is your theoretical outlook. Okay. So I'm just going to leave that there for now. So we've got the reaction produced magnesium oxide, and it says with a percentage yield of 75%. You can use that straight away to work out the actual mass, but we needed the theoretical mass first, which is what we just got from this equation. So you would expect, theoretically, to get 10 grams of magnesium oxide. So that would be the answer to part A. Okay. Now, if the percentage yield is 75%, that means that 75% of this would actually come out in real life. So to work out the actual mass, we can just take the theoretical yield and then multiply that by the percentage yield. So you can multiply by percentage like that. Some people won't like that and would prefer to write 0.75. Any of those are fine. If you're going to write it like this, then you must make sure there's a percentage symbol in your calculator. So 75% of 10 would just be 7.5 grams, and that's what you would get in real life. Okay? So went through that one in a bit more depth, but the next one I'll just go through a lot faster. So I'll just do what you need to do here. Right, so let me just start with this. I'm going to write down my chemical reaction. Alright, so iron's made by reducing iron oxide with carbon monoxide. Student starts with 16 grams of iron oxide, so let me write that in. That goes there. The percentage yield of the iron in the reaction is 84%. Calculate the theoretical mass of iron and then calculate the actual mass of iron produced. So here, just write M as your mass column. Remember MR as well, and moles. MR for iron, okay, so we've got Fe2O3, so that means we've got 2 irons and 3 oxygens. And you can see that they have nicely written the MRs here for you. So that would be 2, let's change that to black, 2 times 56 for the iron, and 3 times 16 for the oxygen. That would give us 112, and this one here would give us 48. So if I add those together, it should give us 160. So I write that there, and if you remember from earlier, I rubbed it out. The moles is the mass divided by the MR. Okay. So that means it's 16 divided by 160, and you should notice that 16 is a tenth of 160, so this would go to 0.1 moles, and that is your iron done. Great, we don't actually need to do anything for this one here. We're only interested in what we're trying to produce. So it's in iron. If you read the question, it says iron is made. Okay, so they're actually interested in the iron. So let's work out this one. So the MR for iron here is just going to be 56, since we just have Fe. This 2 here is for the mole to mole ratio, not for working out the MRs. It's only when you have a number down here that you start doubling. Notice how we had a 2 and a 3 down there for the last one. So, right, so for iron, we just have 56 for its MR, and to work out the moles, we just need to use the mole to mole ratio again. So we should see that there's no number here, so that's basically a 1. There's actually a 3 there, a 2 there, and a 3 there. But we're not interested in all of them. We're only interested in this one, because this is the one we have the moles for, and this one. So notice it's just simply 1 to 2. So to get the moles of iron, I just need to double the moles of iron oxide, which would be 0.2. Okay? And then if I multiply these two together, that's going to give me the mass for iron. So 0.2 times that, if I did 0.1, it'd be 5.6, so it's 11.2 grams. Okay. So that is actually the maximum theoretical, this one. Think of it like that. Okay, that's what you'd expect from theory. But what it's actually saying is that the percentage yield is 84%. So what I need to do then is to work out 84% of the 11.2. So the theoretical mass I've already got. Okay. Actual mass, like we said, we need to use that percentage. So it would be taking the 11.2 grams and then finding out 84% of it. You might want to write 0.84, but I'm going to stick with this one. So 84% of that, let me just calculate it. So we got 11.2 times. See, look, you can use it like this. That'll give you 9.4 grams. And that's how you do it. Okay? So I hope this video helped you out. If it did, please do like and subscribe. That would really help me. There'll be much more chemistry content coming soon, as well as some physics content, some maths content, lots and lots more to add. So just make a suggestion in the comments if you'd like to see anything on this channel. Thank you very much and have a nice day.